All right, we're still on the non-calculator portion of this review. And question number 10 is another arc length formula. And they gave us, nicely, they gave us an explicit formula for the function, and they gave us the limits of integration by giving us this interval. So I set up an integral of the limits of integration being 1 and 3, and then I need the square root of 1 plus the derivative squared. So up here you see we found the derivative. We said that we can pull down the 3/2 times the 2/3. That just goes to 1 times x squared minus 1, and then 3/2 drops a degree to just 1/2. And then I need to multiply by the derivative of my inside function, which is this 2x. So you'll notice I have the square root of 1 plus this entire derivative squared. And I do have some algebra to work out. And if you're ever given an arc length question without a calculator and there's algebra to work out, I promise you that you will always work it out to be a perfect square trinomial underneath the radical sign so that you can actually take a square root and get an even square root and then integrate. So in this case, if I'm squaring x squared minus 1 to the 1/2, that just gets me x squared minus 1 to the 1. And then 2x all squared gets me 4x squared. So now I'm going to distribute this 4x squared to both of these terms here to get 4x to the 4th minus 4x squared plus 1. This is a perfect square trinomial that I can write as the square of a binomial. So when I then take the square root of this binomial squared, my squared and square root cancel out, so I just am integrating 2x squared minus 1, which integrates to 2/3 x cubed minus x from 1 to 3, and then I evaluate first at 3, so I cube the 3 to get 27 times 2, 54 over 3, minus 3, and then evaluated at 1, I get 2/3 minus 1. So 54 over 3 simplifies to, well, you know what I did? I took 54 over 3 minus 9 over 3. So 54 minus 9 is 45 over 3. That's what got me the 15. And then 2/3 minus 1 is negative 1/3. So I'm subtracting a negative 1/3, adding a 1/3 to my 15 to get my final answer.